Hi everyone, I'm Gunashri, studying in Sri Venkateshwara College of Engineering, third sem, branch IC. Today I'll be taking up the topic subject data structures and I'll be discussing about the following topics. Additional list operations, sparse matrices, and what is doubly linked list. So speaking about additional list operations first, so what is data structure? So data structure is basically it is a way of storing data in computer's memory so that it can be used efficiently and easily. There are different types of data structures used for storing different types of data. Here, another definition of data structure is it can also be defined as a mathematical or logical model of a particular organization of data items. There are different types of operations that can be performed to manipulate the data present in every data structures. They are traversing, insertion, deletion. So what is traversing? So traversing means to visit the element stored in it. It visits in a systematic manner that it follows some set of rules and regulations. So it can be done with any type of data structure present. Insertion. Insertion also we can apply on all types of data structures. Insertion means basically to add an element to the given data structures. So this can be implemented successfully when the required element to be added is required in the data structure. Deletion, so which can also be applied to all the data structures. To delete an element in the given data structure, we use a deletion operation. Insertion. So insertion, as discussed or said earlier, it is used to add an element. So it can be performed in two different ways. That is insertion at front, insertion at rear. So what is insertion at front? So in front of the beginning or in front of the beginning of the linked list, we need to add an element to the linked list. So first we have to make the first node of the link list as a new node, then remove the head from the original first link list node, and then we have to make the new node as the head, and then the new node will be inserted at the front. If you want to insert a node at the last, then there are two scenarios that can be followed. So first, the node will be being added to the end of the list directly. So first we have to allocate memory for the new node, store data in the new node, traverse to the last node and change next of the last node to recently created node. Moving on to deletion. So when we delete the node and linked list, then there can be three ways to delete a node. First, deletion at the beginning, deletion at the middle, deletion at the last. If it is at the beginning, then we have to assign the next node in the linked list as a new head and free the previous head already present. If it is at the middle, we have to search the node and we have to go, which has to be deleted, and call it as temp and assign that temp node to the previous node and store the previous node as previous, and particular node which will be assigned to temp will be deleted. If it is at deletion at last, we have to search the node that has to be deleted, call it as temp, and store the previous node that is called, or the next node that is called as next, and the node which will be selected will be deleted at the last. There is something called operation for change. So this is also an operation that will be performed by the linked list. So when we have to manipulate single linked list, then we have to take, it is desirable to build a variety of functions. So there is something already, there is a provision of get node and ret node. So which will get and return the nodes from the available already space list. So inverting or reversing the chain is again another useful operation, because this inverting will be helpful when we do it in place if we use three pointers. So there is some declaration that has to be followed for performing the operation for chains. So the operation is like this: type def, you have to define the structure list as node, we have to store the variables, and we have to allocate the list as pointers. So operations for circularly linked list. So if you want to insert a node at the front of the list, then we have to change the link field, move to the last part of the, we have to move to the last of the linked list. And again, we have to find the last node, remove the last node, and again join the, or link the last node to the first node. But when we use a circularly linked list, it can be done more convenient. Why? Because the last node and the first node will be present, rather than at the front and the end, it will be present beside each other. So this is another one more operation that can be easily performed in the single linked list. So to insert an element, first we'll set the trail to middle, then middle to lead. So lead will move to the linked list, and the middle element, or the element which has to be inserted at the middle will be inserted. To concatenate a list, so first we'll call a temporary variable. So it will check the conditions whether if it is true. If it is true, it will return the concatenated list. If it is false, it will follow the performing operations. Sparse matrices. So the second topic of the of today is, so what is sparse matrices? So this will be having major of the elements equal to 0. So in other words, sparse matrices contains very less number of non-zero elements greater than the 0 elements. So what are the benefits? First, it provides storage and computational time. So storage, so it contains very lesser non-zero elements, so memory can be utilized to store more elements. So has it only evaluates a non-zero element. Computing time, if in case of searching, if we say talk about searching, then only it is required to traverse the non-zero elements than traversing the whole sparse matrix. It reduces the time of performing an operation than the normal matrix operation what we follow. What are the properties of sparse matrices? Storage efficiency, computational speed, increased performance. So as they only have non-zero elements, lesser compared to the zero elements, so it require only less memory to store only the non-zero elements. Computational time, has these matrices involves only fewer calculations to be performed, so it makes them computationally faster to perform all the operations than the other operations, other matrix operation that will be performed. Increased performance, so useful in the iterative algorithms and numerical simulation because of their efficient computation speed. Moving on to the common representation of sparse matrices. So the first one is a coordinate list, commonly called as COO. So here three-way arrays will be used to store the non-zero elements. Coordinates and values will be used. Compressed sparse matrices CSR. So it will simplify the representation to optimize the memory storage by eliminating the zero elements already present in the matrix. Diagonal storage refers to as DIA. So it is efficiently used in matrices. Why? Because with it will contain, if there is a provision of many repeated values, then it will reduce the need to store the zeros. Moving on to the advantages of sparse matrices. First is the memory saving. They save memory by only storing non-zero elements, making or taking rest of all the non-zero elements initialized to 0. Efficient computations. They reduce the number of operations because the whole complete matrices will contain only zero elements more. Improved performance. Complex algorithms benefit from the efficiency of sparse matrices, enhancing overall performance. What are the applications of sparse matrices? They're widely used in the field of computer graphics. So they're utilized in 3D graphic rendering simulations because of their efficiency in representing geometric transformations. They're also used in scientific computation, in physics, engineering, and other scientific disciplines because of the computational speed. They're also effectively used in machine learning, where they handle high dimensional and sparse data sets efficiently. Moving on to the doubly linked list. So it is a complex type of linked list in which a node will contain a pointer to the previous as well as the next node in the sequence. Therefore, in doubly linked list, a node consists of 3 parts. That is the node data, pointer to the next node in the sequence, and pointer to the previous node as shown here. The following, particularly in C, if a node is present in a doubly linked list, the structure is defined as follows. Struct node into previous in data, struct node into next. Struct node previous will store the previous, the data. I mean, if the data is in the middle, then it will store the previous element in the node, and next will store the next element in the node. So how a memory will be represented in a doubly linked list. So it is shown in the following image. So it will consume little more spaces for every node, and it is more expansive. Basic operation like insertion, deletion has to be followed in a more complicated way. So the same following thing will be present. Struct node into previous. We have to in data, that is we have to declare the variables present, and at last it is as it follows a structural program, the following operation will be followed. So how to do traversing a list in the double A linked list? So it can be done in either direction, either traversing forward direction or in the backward direction. So it is almost called iteration, but iteration is well-defined semantics, which is not analogous to traversal. So the following code will be used to traversal the given list in a forward way. Traversing a list in a backward way, the following code, that is node, will be initialized first into last list dot last node. If the node is not equal to null, then it will perform the following block of operation. And once if it is equal to null, then the traversing part will be exiting the block of code and will stop the execution. How to insert a node in a doubly linked list? Either it can be done before or after a given node. If it is after a given node or insert after, then the first we have to specify the list node, the node, and the next node or the new node. So for example, new node dot previous is equals to node. If node dot next is double equal to null, then and the new node will be created, and next will be initialized to null. List dot list node will be equal to new node. If not, else part will be executed. Removing a node from the double linked list. So it is easier than insertion, but it will also require special handling in a node. First, we have to check whether before the function remove, we will declare the variables, that is the list and the node. If node is equal, node dot previous will be equal to null, then it will remove the first node, or it will enter the else part, where we'll define both the previous node and the next node, and it will check whether it is equal to the next node. So if in case the next node is equal to null, then the last node will be set to the previous node, and else the next previous node will be set to next node the previous node present. So these were the few topics I discussed here in this video. So conclusion, speaking first about the first topic, that is the additional operations on single linked list. So these are essential for optimizing data structures such as concatenation, insertion, deletion, traversing. All these list operations were essential for optimizing data structures. So we can enhance the sorting, slicing techniques, and also the efficient and functionality will be used in a greater way. Coming to the second topic and concluding the second topic, the sparse matrices. So it is used in achieving efficient data representation and processing. These using sparse matrix techniques, we can lead a sustainable gains in memory utilization and computational efficiency across the different diverse applications present in the today's world. Speaking about double A linked list, so from efficient data storage to seamless traversal, this particular data structure, it will offer users a wide variety of advantages to perform different operations efficiently and more easily. This was all about the basics or some of the parts of the data structure. I hope this video was useful. Thank you for watching.